Today's lesson is all about 1.7. In 1.7, we're going to focus on two formulas. One of those formulas is the midpoint formula. Now, the midpoint formula can be broken up into two separate formulas depending upon the situation you are dealing with. The first situation we are dealing with is the number line. When dealing with finding a midpoint on the number line, you can deal with it either visually or you can utilize a formula. The formula involves finding the coordinates. You need to find the coordinate for A. So please recall, a coordinate is the numerical value associated with the point. We're also going to find the coordinate of B. So the numerical value associated with B. We're then going to add these two numbers together and then divide them by 2. So the midpoint formula when dealing with the number line is A plus B over 2, or the coordinate of A plus the coordinate of B cut in half. Okay. One way you could also look at this is just doing a visualization, okay? So what that formula is actually doing is finding that total distance and then going in or from the left or in from the right by that distance to find that midpoint, okay? I believe that's actually an approach many of you take when finding the midpoint. The other midpoint formula that I need you to recall is when you're dealing with a coordinate plane. So if you're given 2 points, A and B, okay, you need to utilize the coordinate for A. The coordinate for A we're going to call x1 and y1. So we're going to let A's coordinate be x1 and y1. And we're going to let B's coordinate be x2 and y2. If we use those values to find the midpoint of these two coordinates on the coordinate plane, similarly to how I did on the number line, all I need to do is add the corresponding x values. So x1 plus x2. And then I'm going to cut them in half. That's going to find me the x value of the midpoint. I'm then going to take my y values, I'm going to add y1 and y2, and again, I'm going to cut them in half. And that'll find me the y coordinate of the midpoint, okay? One approach you could also take visually is noticing that to get from A to B, you're essentially running to the right or to the left, and then rising either up or down. Okay, utilizing the concept of slope. And then, to get halfway through that distance, all you would need to do is travel half the run and half the rise. That's essentially what your midpoint formula is doing. Let's do an example. And we're going to show our work algebraic because that is always an expectation that I have of you. Segment AB has endpoints of -4 and 9. So these endpoints, these values right here, these are the coordinates. Okay? What is the coordinate of the midpoint? So recall, to find the midpoint, all we need to do is add the coordinate of A to the coordinate of B, and then I'm going to cut them in half. Okay? So the coordinate of A is -4. The coordinate of B is 9. Divide this by 2. Well, I'm first going to work in the numerator. -4 plus 9, that gets me 5 over 2. 5 over 2 is a decimal value of 2.5, so the coordinate of my midpoint is a coordinate of 2.5. It's perfectly acceptable to get a decimal answer. Personally, I'm a huge fan of leaving them as improper fractions. I'm just going to leave mine as 5 halves. Because our midpoint was a decimal, this is a situation where showing your algebraic work is helpful versus using a visual approach. All right, the next one. Segment EF has endpoints at E, 7, 5. F is 2 at -4. What are the coordinates of its midpoints? Okay, we're going to let the coordinate for E be our values for x1 and y1. And we're going to let our coordinate for F be our values of x2 and y2. Okay, so then I'm going to write my formula here just to give myself a point of reference. x1 plus x2 all over 2. We're going to have y1 plus y2 all over 2. And this is what I'm going to use to find the coordinate of the midpoint of this segment. All right, so x1 is going to refer to the x value of E, so 7. x2 is going to refer to the x value of F, so 2. And I'm going to cut that in half. y1 is going to refer to the y value of E, so that's going to be 5. y2 is going to refer to the y value of f, so negative 4, all over 2, so I'm cutting it in half. Once again, I'm just going to work first in my numerator. So we're going to have 7 plus 2, that gets me 9 over 2. 5 plus negative 4, that gets me 1 over 2. This is a perfectly acceptable answer, leaving my answers here in terms of a fraction. If fractions are really bothering you, if you can't stand those fractions and you want to convert them to a decimal, you can always convert this. 9 halves is the same as 4.5, and 1 half is the same as 0.5. Both of these answers preserve the accuracy. They are both very precise answers because I did not need to round. Here is your first got it that you are going to answer on your screen on your Edpuzzle. Please take time to answer both question A and question B. Now that you found out if you're right or wrong, let's look over your work. Here are the steps that you should take for 1A and for 1B. Feel free to pause at this time and look over the work and see if you can find your mistake. Now we're going to do a little bit of other words motion using our formula. In this situation, what I've been provided is a midpoint, but I've also been provided one endpoint, and we need to find the other endpoint, D, okay? So we're going to let C represent the coordinate for x1, y1, and we're going to let D represent the coordinate of x2, y2, okay? All right, so our midpoint formula is x1 plus y1 all over 2. I'm sorry. Look at that. Miss Rudolph's making a mistake. Don't do math at 7 a.m. x1 plus x2 all over 2. We got y1 plus y2 all over 2. Because I've been given a midpoint in this scenario, I'm going to set this equal to our midpoint, because that's going to remind me that these components are associated with the proper midpoint, okay? So I'm first going to focus my efforts on my x values here. Here are my x values. So I'm going to say negative 2 is equal to my value for x1. x1 is associated with the x value of c, so negative 5, plus I don't know the x value of the coordinate d. So now what I have is an equation to solve for the x value of d. I'm also going to set up an equation to solve for the y value of d. So my midpoint had a y value of 1. I'm going to set this equal to, well, we need our y value of c, so that's 7, plus we don't know our y value of coordinate d, all over 2. In both of these equations, I'm going to solve them simultaneously. I'm going to multiply everything by 2, okay? That's going to get rid of my denominator on this side of my equation. And now I got to remember to multiply my other side by 2. 1 times 2 is 2. So now we have 2 equals 7 plus y. When I do that over here, the 2's cancel out, but I got to remember to multiply negative 2 by 2, getting me negative 4. So here are both of my equations, and then in both my equations I just need to solve. So we need to add 5 onto both sides. So negative 4 plus 5, that gets me 1. This is my x value. When I subtract 7 from both sides, 2 minus 7 is negative 5. This is my y value. Because you are finding a coordinate, this is not a proper way to let my answer stay. I need to write my answer in coordinate form. So my coordinate is 1, negative 5. This is the location of my midpoint. Once again, it's now your turn. Here is your got it. Once again, you're given a midpoint and you're given one coordinate. You need to find the missing coordinates. Take some time to answer the question on your Edpuzzle. All right, you now know if you are right or wrong, so take a moment to look through the work. The setup should be identical as to what I just did on the board, but maybe you can use this time to find a mistake if you have one. The other formula that we need to discuss today is the distance formula. Hopefully this is another formula that you have seen once or twice before. The distance formula is going to find for me the length of a segment, or the distance between two coordinates in the coordinate plane. So once again, if we let A be the coordinate of x1, y1, and we let b be the coordinate of x2, y2. Notice the subtle differences between our midpoint formula and our distance formula. The distance formula, the distance is equal to the square root of an entire quantity. The quantity that I'm taking the square root of. I have a quantity where I'm subtracting my x values and then squaring it. And then I'm going to add this to the quantity of, I'm going to subtract my y values and square it. Please notice I need to remain consistent. If I'm first going to use a x value from my b coordinate, I need to first use a y value from my b coordinate in the formula. Therefore, leaving my a coordinate to be second in line in both quantities. All right, here comes my example. Don't do your got it. I got to do mine first. So what is the distance between these two coordinates? All right, I'm going to let u be my value of x1, y1, and I'm going to let my v be my coordinate of 4, negative, oops, that's given information. Once again, Miss Rudolph, screwing up when no kids are watching. We're going to let v be a coordinate of x2, y2, okay? I like to do that just to give myself a frame of reference here. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember, this entire quantity, I'm taking the square root of it. All right, here we go. My value of x2 is going to correspond to my value of 4. My value of x1 is going to correspond to my x value of negative 7. So we have minus a negative 7. I'll deal with that in a second. Y values. My y2 corresponds with the value of negative 3. My y1 corresponds with the value of 5, so we have minus 5. Please remember order of operations. Order of operations says I first must work on the inside of my parentheses. So we have negative 4 minus negative 7. That becomes 4 plus 7. 4 plus 7 gets me 11. So we have 11 squared. Plus negative 3 minus 5. Negative 3 minus 5 gets me negative 8. So we have negative 8 squared. All right, after we work inside of our parentheses, PEMDAS says then we work with exponents. Now we need to do 11 squared. 11 squared is 121. Negative 8 squared is equal to 64. So now we have the square root of 121 plus 64. Now I can add these two numbers together. So 121 plus 64, that gets me 185. In the directions, it told me to round to the nearest tenth. So I'm going to type in the square root of 185, and I get a decimal of 13.6. Rounding to the nearest tenth means I should have one decimal place. Okay? All right, it's now your turn on your Ed puzzle. Please find the distance between these 2 points, and again, round it to the nearest tenth. All right, now is your time to check your answer. Okay? I do believe we found an error in this last year. I believe the answer on this one's actually 16.8 when they typed in the square root of 25 plus 225. So hopefully I made sure that was correct on your Ed puzzle. Last example, this is a quote-unquote real-world problem. It's just giving you a different context to look at. And in this problem, we have a zipline course on a map. We start at platform A, and we zip from platform to platform. I'm actually going to be doing this on my honeymoon this year. I'm very excited about that. How far do you travel from platform B to platform C? Here is the main question. Essentially, what I'm asking you is the distance between the coordinate for B and the coordinate for C. So it might be helpful for me to point out the coordinate for B. According to this grid, my coordinate is negative 30, negative 20. According to my grid, my coordinate for C is located at negative 15, positive 10. Okay? If you're struggling with remembering how to identify coordinates, maybe try some Googling tonight, and then tomorrow you can always ask for a clarification. All right, we're going to let our x values here. Let's let these be our x1 and our y1. And we'll let these be our x2 and our y2. All right, so distance formula, I'm going to write that down for myself. The square root of x2 minus x1 squared plus y2 minus y1 squared. Now, remember, it actually doesn't matter which one you use first, as long as you're remaining consistent. So here we go. We got the square root of. My value for x2 is going to be negative 15. My value for x1 is negative 30, so we have minus negative 30 squared plus. My value for y2 is 10. My value for y1 is negative 20, so minus negative 20 squared. Remember, this is all under square root. Again, I'm going to obey order of operations. I'm going to first work inside my parentheses. So negative 15 minus negative 30. That becomes negative 15 plus 30, getting me 15 squared. 10 minus negative 20 gets me 10 plus 20, so we have 30 squared. Once again, next I just need to make sure I use my exponents here. 15 squared gets me 225. 30 squared gets me 900. Then I'm going to combine these to become the square root of 1,125. And then once again, I'm actually going to give myself the luxury of rounding, so I'm going to type this into my calculator. The square root of 1,125 is 33.5. Now, because this problem is a real-world problem, I need to remember if I'm dealing with a unit. Because according to this grid, my sentence says I'm in terms of meters, I'm going to write meters as my unit of measure, giving myself a complete answer. Here's your last guided question. Take some time to solve it. All right, you should know if you're right or wrong, so please take the time, pause, make sure you understand if you have a mistake. All right, I look forward to seeing you tomorrow in class. Have a great day.